Let's discuss a question from thermodynamics. Well, let's read out the question first. One side of the chamber contains ideal gas, and you can see the figure, the other side is evacuated, and the entire chamber is insulated, so heat cannot pass through it or cannot go from it, and both sides separate by diaphragm. Now, the question says that when the diaphragm is ruptured, obviously the gas will fill up the entire chamber. Which of the following statement is true? Okay. So now this question, it is asked whether the internal energy and enthalpy, which of them remains constant and stuff like that. Okay, so let's first consider a system which is the entire thing as our system, the entire thing. So you have a diaphragm which gets ruptured, and this entire ideal gas flows and it fills up the entire space. Okay, so we consider both A plus B and both 2V as our system. And for this system, if we apply the first law, which is Q is equal to change in internal energy plus W. Now Q is the amount of heat. So the process here is when you rupture it, the ideal gas fills up. So from state 1 to 2, which is from no rupture to there is the gas being filled in only one chamber to the gas which is filled in other chamber. And this is the heat transfer in 1 to 2 and the work done in 1 to 2. Now we know that because the entire we have considered this entire thing as our systems, and the entire thing is insulated, so the heat transfer is 0. Okay, and this is the change in internal energy plus. Now work done is also 0 because, so let's write this is because of insulated. And why the work done is 0? Because it's just a case of free expansion. There is no resistance. Whenever like a balloon bursting or when a diaphragm is rupturing and the gas coming out suddenly, there is no resistance to the gas. So we cannot say, we in fact cannot say there is work done by the gas because you have not measured that work done. There is no resistance to the, always when you say the work done, some amount of work is done by the system when you have a restriction imposed on the system, like say a piston work. So when the gas is trying to expand, but you have a piston on the top which is resisting and which is providing the same amount of force which the gas is exerting on the piston, then if you measure the work, then you say that the work is done by the system. So in the case of free expansion, like the balloon bursting or the diaphragm rupturing, there's no work done by the gas. So from this first law we conclude that internal energy is constant, U is constant, there is no change in internal energy. Okay, so this is one thing. Now as it is given that it's ideal gas, and for ideal gas one of the assumption is that internal energy is a function of time. This is not an assumption. In fact, this is proven by experiment that for ideal gas, internal energy is a function of temperature. Okay. Now we also have a fact. Now we need to conclude about enthalpy. So enthalpy is U plus PV, and we know that from the ideal gas thing that PV is nRT, and we also know that for ideal gas, this is from experiment, that it is a function of temperature only, and so this entire thing becomes a function of temperature only. So now comes a fact that because U is constant, and combining with this fact that internal energy is a function of temperature, we conclude that temperature is also constant in this process. As temperature is constant, we conclude that enthalpy is also constant. So you have to just use the first law, use this ideal gas assumption. I mean, the ideal gas, it's not I'm sorry, again, it's a proven fact from experiments that for ideal gas, U is a function of temperature, and this enthalpy definition. From all these three facts, you can conclude that internal energy is constant as well as enthalpy is constant. So the answer for this is option C, which means both are constant. Thank you.